Alright, this is part 2 of the lesson. And here is the bulk of your assignment. So I'm asking you to simplify each trigonometric expression. And I'm going to give you an example. Well, I'm going to give you lots of examples, actually. I'm going to start with cosine theta times tangent theta. And our job is to here's how we think of simplifying in my perspective. Simplifying is taking a hot mess and turning it into a lukewarm mess. So it's still going to look kind of weird sometimes when we're done, but it's going to look less weird. Here's my biggest ideas I can convey when simplifying, because you're like, how the heck am I supposed to simplify this? I'm going to give you some tips to simplify. Tip number 1 for you is to write everything in terms of sine and cosine. So let's take a look at part A here. I'll give you another tip while I'm at it. So you write everything as fractions. So part A, prime example. Cosine theta is already written in terms of cosine because I'm thinking cosine. So I'm going to write this as cosine theta, and I'm going to put it over 1 to create it as a fraction. You're about to see why. Now, it's being multiplied by tangent of theta, but the identity that I just learned is that tangent is the same as sine theta over cosine theta. Now I have a bunch of multiplication and division. Well, I can see that these cosines are going to cancel each other out, which just leaves me with sine theta. And that's it. I could do another example of this. Let's do cotangent of theta times secant of theta. All right, these are my nice reciprocal identities coming in. And I'm going to start with cotangent. I'm going to go back to the previous slide for this. Cotangent was 1 over tangent, but it's most helpful in these situations to write it in terms of sine and cosine. So I'm actually going to put my focus here, is that cotangent is the same as cosine divided by sine. Okay, so cosine divided by sine is cotangent, and secant, maybe I'll have to write down these identities so we don't have to keep going back and forth. I look at secant, and I see that secant is 1 over cosine. So my cosines cancel. I'm left with 1 over sine theta. I can go back to my identities. 1 over sine theta is the same as cosecant. So this is cosecant theta. A lot of question I get with this when we get to this stuff is, how do I know when I'm done? Just go until you cannot go no more. That is what I say. Let's do another example. All right, let's do sine theta divided by tangent of theta. Oh, okay. All right, tip number 3. I want you to split up your numerator and your denominator into separate fractions. Here's what I mean by this. I have sine theta divided by tan theta. I'm going to make sine theta its own fraction by just taking it as a numerator and putting it over 1. I'm going to make tan theta its own by putting 1 over tangent. So now I have their own fractions because now I can deal with each of those separately. So I know sine theta stays the same. 1 over tangent, oh, hey, let's look back. 1 over tangent is the reciprocal identity of cotangent. Cotangent is cosine over sine. Sines cancel. I'm left with cosine theta. I could do the same thing, like I can give you tangent theta over secant theta. I'm going to split up that fraction, tan theta over 1 times 1 over secant. Tangent, I know, is sine over cosine. And secant, well, notice, because this is 1 over secant, this is looking for a reciprocal of secant. Well, if secant is the reciprocal of cosine, that also means that the reciprocal of secant is cosine. I'll write that in blue. Oops. So now those cancel and I'm left with sine. And this is pretty much just the process you're going to take for everything on your homework. I'm trying to find if there's one that really comes out different. Here, I'll do 2 more examples for you. Okay. By that I meant 3 more examples. I think just seeing the examples becomes very helpful. Okay, cosine over secant. It's like cosine theta over 1 times 1 over secant. The reciprocal of secant is cosine. Well, now I have 2 cosine. A cosine times a cosine means cosine squared. Just notation-wise, the way we write that, the squared goes on the cosine, not the theta. If the squared was on the theta, it would look like you'd be squaring the value of whatever theta is. So like if your angle was 30 degrees, it looks like you're squaring 30 degrees. So that's why notation is putting the squared on the cosine part. I could give you, let's see, cosine theta minus sine theta times cotangent theta. That one looks fun. I'm going to leave that cosine theta out there by itself. Minus sine theta. Cotangent is the reciprocal of tangent. I know tangent is sine over cosine, so that means cotangent is cosine over sine. These signs are going to cancel. So I get cosine theta minus cosine theta. hey, what's anything minus itself? 0. Great. Let's do one from your homework. Let's do homework number 23. Yeah, this one looks real fun. All right. All right, I'm going to start by splitting up everything. And I'm actually going to do this. I'm going to take my sine squared here, and I'm just going to go sine theta times sine theta. So that's what it means for something to be squared. Okay, cosecant theta, that's the same as 1 over sine. Secant theta is 1 over cosine. And now I'm going to separate this tangent out here. That's where that's coming from. So I can write all that again. Tangent, 1 over tangent, that is reciprocal of tangent, so that's cotangent. Cotangent, I know, is cosine over sine. And now I can just cancel out everything. So there's a sine, there's a sine, there's a cosine. Everything canceled out. So I'm left with 1. All right, so that is day 1 of trig identities, humans. Good luck on your homework. Please shoot me an email if you need some help or want to set up a video conference or anything like that.